Alright, 10.3, apply properties of chords. Now, if you guys remember, a chord looks something like this. They are segments whose endpoints lie on the circle. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So, arc AB is congruent to arc CD if and only if the chord AB is congruent to the chord CD. Okay, so for example, in the diagram, these two circles are congruent. Also, the chords BC and EF are congruent, and the measure of arc EF is 125 degrees. Find the measure of arc BC. Okay, so this equals this. This is 125 degrees. Hopefully you guys can see that this also has to be 125 degrees. Okay, because BC and EF are congruent chords in congruent circles, congruent's already written, circles, the corresponding minor arcs BC and EF are congruent. So the measure of arc BC equals the measure of arc EF, which equals 125 degrees. Alright, theorem 10.4. If one chord is a perpendicular bisector, remember perpendicular means it makes a 90-degree angle, and bisector means it cuts it exactly in half. Okay, so if one chord is a perpendicular bisector of another chord, then the first chord is a diameter. Okay, so if you have a chord and it's being intersected by another chord in such a way that it makes a right angle and it cuts it exactly in half, this chord has to be a diameter. Okay, so if QS is a perpendicular bisector of TR, then QS is a diameter of the circle. Theorem 10.5. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So, if you know this is the diameter, and there's some other chord that intersects the diameter in such a way that it's perpendicular, then it bisects that chord. So if EG is diameter and EG is perpendicular to DF, then HD is congruent to HF and arc GD is congruent to arc GF. Alright? Okay, let's go on to page 2. Example 2. A journalist is writing a story about 3 sculptures, probably these, arranged as shown at the right. Where should the journalist place a camera so that it is the same distance from each sculpture? Okay. Label the sculptures A, B, and C. Draw segments A, B, and BC. Okay, so let's do that. Actually, I think they have it down here. Alright, so ignore this. They drew it nicely down here for you. Okay? So, we'll say this is A, this is B, this is C, and we draw it. Draw the perpendicular bisectors of A, B, and BC. So, if this is AB, I'm going to draw a perpendicular bisector of AB. So it makes a right angle and it bisects it. I'll also draw a perpendicular bisector of BC. Right angle and it's bisected. By theorem 10.4, these are diameters of the circle containing A, B, and C. Okay, so all we have to do is figure out where these perpendicular bisectors intersect, and that's where we want to place our camera. So we find the points where the bisectors intersect. This is the center of the circle through A, B, and C, so it is equidistant or equal distance from each point. Alright, example 3. Use the diagram of circle E to find the length of BD. Okay, so here's BD. This looks like a diameter. Tell what theorem you use. Diameter AC is perpendicular to BD. So by theorem 10.5, AC is perpendicular to BD, and BF equals DF. Then it bisects it. So if this is 6, then this also has to be 6, which means the whole thing has to be 12, because 2 times 6, 2 times BF, I guess, or FD. FD and DF are the same. I guess I could write it the same way. Or 2 times 6, which is 12. Okay? Alright, 10.6. In the same circle or congruent circles, 2 chords are congruent if and only if they are equidistant from the center. Okay, so AB is congruent to CD if and only if this equals this. EF equals EG. Okay, let's go on to page 3. In the diagram of circle F, AB equals CD equals 12, and that's labeled. Find EF. Okay, chords AB and CD are congruent, so by theorem 10.6, they are equidistant from F. Therefore, EF equals GF. EF equals GF, so 3x equals 7x minus 8. I'm going to add a few steps. If I subtract 3x from both sides, actually, let's do it the other way. Let's subtract 7x from both sides. So I'm going to get negative 4x equals negative 8. Divide by negative 4. X equals 2. So EF equals 3x, or 3 times 2, which is 6. Alright, and you guys can do the checkpoint. That's all.